Hey guys, welcome to the third and final part about painting with color and light. In this video we'll finally get into the very deep stuff, so make sure to watch the first two parts. And today we'll figure out how to paint reflections on water, glass, and how translucency affects color. Let's start with reflections on the surface of water. It's a very complicated subject, but I'll try to keep it as simple as possible. The angle at which we look at the water and the angle at which the light falls on it will determine if the surface acts as glass or is a mirror. The sharper the angle of light or our gaze, the more the surface of the water will resemble a mirror. The straighter those angles, the more transparent the water will appear. In usual daylight, the surface of water will look something like this. Up close, we'll be looking at the water surface from a right angle, so the surface will be pretty transparent. But as we look further away, the water will look more and more like a mirror. But let's talk about the difference between reflections in mirrors and glass. While a mirror reflects both dark and light objects, glass reflects only light. That's why if you're outside a house at night and the lights there are on, you can see everything that's going on in there, but you won't be very visible to those inside the house. This happens because people inside see everything bright reflected in glass, which prevents them from seeing you. But you have nothing bright on your side and the glass doesn't reflect anything. For the same reason, if it is on the contrary bright outside and dark inside the house, we have to press against the glass and block the light with our hands to see. The glass kind of works like a layer in screen mode. Therefore, glass reflects light according to its brightness, and as objects and light become darker, the transparency of the reflection will decrease. Let's look at an example. In the picture on the left, we look at water from more or less right angle. We are looking from above, so the surface of the water is a bit like glass because it reflects only the lightest thing, which is the sky, and we can see the part of the dress that is under the water. In the picture on the right, our view of the water falls from a more obtuse angle. We're just slightly above the surface of the water, so notice that we do not see what is submerged in the water, but only see the reflection of what is above the water as if it was a mirror. But of course, it's not as simple as I said. At times, it all depends on the angle and type of lighting, the cleanliness of the water, and of course the flatness of the surface. The less flat the water surface will be, the more fun distortions we'll see up close and vertical lengthening of reflections in the distance. But I can talk about all possible cases today, so look for references, learn from them, and apply to each individual case. And now let's talk a little bit about small bodies of water. For example, water drops in glasses of water. Their shadows look very cool in bright light. Why so? Well, it happens because of light refracting while passing through material density change. The rounded shape of the body of water bends rays of light in different directions. In addition, the rounded shape of the body of water bends rays of light in different directions. Depending on the size of the object and other factors, the rays may even have time to separate in different directions. Remember that term from your physics class, focal point? Beyond this point, the image begins to flip. This happens with any transparent spherical object. Let's take a look at these droplets. It is important to understand that they are usually half of a sphere. What happens is that the refracted light accumulates inside the part of the droplet which should be in the shade because it is further away from the light. But the paradox is that this part of the droplet is even lighter than the part closer to the light itself. The point of focus, that is the point where the refracted rays would come together, is under the surface on which our droplet rests. In glasses, spheres, and transparent objects which have a more complete spherical shape than a half of a sphere that droplets have, the point of focus may extend beyond the object and the refracted light accumulates in the shadow. And as you may have noticed, the ball on the right is not completely transparent, it's just translucent. So let's talk about that. In fact, many more materials than we think are actually slightly translucent. Skin, hair, plastic, and even some minerals like marble have a small percentage of translucency. I think I don't have to explain to you how translucency works, you can figure it out by yourself, but there is one thing which some of you might not have known or noticed. When light passes through a surface, it makes the color of the object richer. This happens because light is colored not only by particles on the surface, but also by all the particles inside the object. You can see this effect in the way that skin turns red when light shines through it, and how much richer the greens appear when the sun goes through them. Also, you probably noticed that your hair looks more saturated, even maybe red sometimes, when the light passes through it. The same thing happens here. And now I would like to say a few words about how this same effect works in the transition between light and shadow. you've probably seen artists make this transition more saturated. And this is partly because a certain portion of the light in the light and shadow transition passes through the surface and is accordingly charged with some more color saturation than rays that are simply reflected off the surface in the area of the light. But actually, there's another reason why this effect can happen. Perhaps it is also due to the scattering of light beneath the surface. That is, perhaps that part of the light that is not reflected but absorbed by the object is scattered inside and charges the object itself with light, so to speak. The more transparent the surface, the more noticeable this effect is. Some artists add this effect for one of those reasons, but in most cases, I'm sure they just enhance it because it just looks so cool. And I just can't stop admiring how beautiful light and color and all of their interactions in the nature and everywhere. And I think that's a great point to end this video because I've already dumped a lot of information on you, so hopefully it was useful. This will probably be the last part of this video series about light and color because I feel like I've shared everything that I've learned so far with you guys. So if there's anything else that you know that I might have not mentioned that might be useful, please let me know. Maybe I'll make a part 4 one day. But thank you for watching, draw and don't slouch!